Due to the extension of the Budapest metro network and the soon actual withdrawal of the existing obsolete rolling stock, BKV, the Budapest Transit Authority, requires a number of up-to-date metro stock. To meet this requirement, the investment company Metrober placed an order in 1983 with the Ganz Mávag and Ganz Electric Works to develop and supply a 6-car prototype metro set, representing economical and technical considerations, efficiency, reliability, and up-to-date high technical standard. Main guidelines in the design work were high safety of service, energy saving, long lifetime, low maintenance requirements and cost, high comfort level for the passenger and the driver as well, combined with ergonomical considerations, aesthetical design. The basic operational configuration is a twin-car unit, where the electric equipment is divided on the 2 cars. 6 car sets are composed of 3 twin-car units. The car body is a monocoque fabricated structure, made of mild structural steel. Frame members are hot-rolled and cold-bend profiles. The structural parts are provided with special corrosion protection. The design of the vehicle enables mechanical washing and cleaning. Passenger rooms are furnished with upholstered longitudinal seats along the side walls. The floor is covered by anti-slip washable plastic material without hatches. Forced ventilation supplies the internal spaces with fresh air noiseless. Electropneumatic plug-type sliding doors are operated by the driver from the cab. Pressing the door close button, the passengers are warned by light and acoustic signal before the doors close. If any of the doors cannot close properly, the control system repeats the opening and closing automatically. 4 broad twin-leaf passenger doors on each car side ensure the fast passenger flow on the stations. In case of an accident or breakdown in the tunnel between stations, the passengers may leave the train through the intercar gangways and through the escape door on the front part of the driver's cab on both ends of the set. The fabricated bogies are connected to the car body by a slewing ring, transmitting horizontal forces. The 2-stage suspension is ensuring a smooth, comfortable riding quality. The longitudinally mounted traction motors are flanged on both ends to the bevel gear axle drives, attached to the bogie frame by resilient members. The axle drives are connected to the wheelset axles by flexible hollow shaft joints. The rated power of the 750-volt chopper-fed DC Series 1 traction motors is 280 kW. A brake disc is placed on each wheelset axle for stopping and parking brake application and as a backup brake if the electrodynamic brake fails. Primary suspension is formed by elastomer springs applied between the axle box and the bogie frame. Air springs connect the bogie frame to the car body, forming the secondary suspension. The floor height is maintained irrespective from the actual passenger load. Resilient wheels reduce the noise and vibrations. Current collectors are mounted on both sides of the extreme bogies of each twin set. All wheel set axles are fitted with back current brush devices. The opposite side axle journals are the location of the speed signal generators for speed control, slip slide control and brake control duties. An aspect of the design philosophy was not to conduct the 750 volt above the underframe level. The only exception is the force-ventilated preheating equipment placed under the seats. This device is only for yard operation. All the other power equipment are underframe mounted. The electrical components placed in cases are well maintainable or easy replaceable from the car sides. The electric power equipment on each twin unit is protected by the main circuit breaker. Electronic measuring transformers are located above the manual power circuit switch. A natural ventilated open-core reactor and condensers reduce the waves of the supply current. The condensers are distributed to the two choppers of a twin unit. The reversal switch and the switches of the power and auxiliary circuits are electropneumatic operated. Close to the switches are located the field weakening resistors and the starting resistors of the air compressor motor. A chopper equipment on all cars each feeds the two parallel connected traction motors through smoothing reactors. The force-ventilated choppers are built of replaceable modules. Quick-acting fuses are protecting the semiconductors. The metro set is controlled by the power brake controller in the main driver's cab. The control principle is the speed control. Pushing the controller handle from neutral position, a speed signal, while pulling back it, the braking force is controlled. To provide an equal acceleration or brake retardation on all cars of the set, the control signals are corrected by passenger load sensors. The main brake system of the set is the electrodynamic regenerative brake. As a backup brake, a direct-acting one-line electropneumatic brake system is provided. The electrodynamic brake application interlocks the EP brake, which comes into action automatically if the dynamic brake fails. All the auxiliaries are switched from the main driver's cab. Optical and acoustic signalization informs the driver permanently about the operation and eventually the faults in the equipment. Two fault indicating displays on the driver's desk and light emitting diode signal lamps on the back wall panel of the cab provide the necessary information about the cars in the multiple unit set. All the cars are provided with electronic control and regulator equipment built of modular printed circuit racks. To improve the work conditions of the driver, the cab is air conditioned. Auxiliary driver's posts are provided on all non-cab end of the twin units. Opening the cover of the control box, yard movements are available with a limited speed. Central microprocessor data registration unit stores the most important characteristics of the vehicle and the power equipment during service. Results of the prototype test program are proving that the set is meeting all the expectations and requirements. The new metro set of the two Ganz companies was constructed for the north-south line of the Budapest metro system. Nevertheless, its design and equipment make it suitable to operate at any other system under various conditions. This presentation was made by the Ganz Video Studio.